Hi, Assalamualaikum and hi everyone. The subject BERG3743 Electromagnetic Field and Wave. Okay, this is our project metal detector. Group members SULAIMAN TANJUNG, AHMAD NAJMI, BURHAN SHEIKH, Mohamad Yusuf, LUKMANUL HAKIM. Okay, introduction. A metal detector is an electronic device used to find metal objects that are hidden underground or inside or the material. It's worked by sending out a magnetic field through a coil of wire. When this field hits a metal object, the device sends a change and alerts the user with a beep or a light. In this project, we have built a simple handheld metal detector to demonstrate how hidden objects like coins, wires, or nails can be found using basic electronics. Block diagram. To understand how this device works, let's look at the functional block diagram. The system begins with a DC power source which provides the energy for the entire circuit. This power is fed into the oscillator stage. The oscillator converts DC into a higher frequency AC signal, which is sent to the surge coil. When the coil is near a metal object, the magnetic field induces eddy currents in that metal. This creates a damping effect, which then energy from the oscillator and change its output. This change is detected by the switching stage, which is as a bridge to our output stage. Finally, when metal is detected, the system triggers an alarm signal via an LED and a buzzer.
In schematic circuit, moving from theory to design, here is the detailed schematic of our metal detector. We can break this down into three main transistor stages. In Q1, transistor Q1 along with the surge coils L1 and L2 and capacitor C2 and C3 forms a high frequency oscillator. The resistor R1 and the potentiometer RV1 allow us to fine-tune the sensitivity. By adjusting RV1, we set the circuit to a critical point where the oscillation is just barely maintained. For detector, in Q2, this PNP transistor monitors the oscillation. When a metal object is brought near the coil, the eddy current damping causes the oscillation amplitude to drop. This changes the bias on Q2, causing it to turn on. For the output driver, in Q3, once Q2 is active, it triggers Q3. This transistor acts as a power switch for the peripherals. When Q3 conduct, current flows through the buzzer, and the LED providing both an audible and visual alert to the user. Sits act as a filter to stabilize the output signal. This is the circuit connection that applies to the physical PCB. On the left, you can see the amplifier board. A key feature here is the integrated surge coil. Rather than using a bulky wire coil, the inductor is etched directly onto the PCB in a spiral pattern. This ensures a compact design and consistent inductance. On the right side, we have the final assembly unit. You can see the placement of the electrolytic capacitor, the 3 transistors, and the blue terminal block for the DC power input. During the soldering process, we ensure the buzzer and LED were positioned for maximum visibility and sound projection. To operate the device, we simply power it on and adjust the onboard potentiometer until the buzzer just stops. When it passes over a coin or metal plate, the alarm triggers instantly.
After that, I want to tell you about the principle and theory for this project, which is metal detector. A metal detector operates based on the principle of electromagnetic induction. Works by creating a changing magnetic field using a coil. When electricity flows through the coil, it produces this magnetic field around it. If a piece of metal comes close, the metal forms small current called eddy current. This current disturbs or weakens the magnetic field created by the coil. The circuit inside the detector senses this disturbance and recognizes that a metal object is nearby. Then, according to Faraday law, a changing magnetic field induces eddy current in nearby metallic objects. This eddy current generates an opposing magnetic field, following Lenz's law, which interact with the original coil field. The interaction causes measurable change in the coil electrical characteristics such as effective inductance, loss resistance, and oscillator amplitude.
This slide shows the ideal state of our metal detector, how it behaves when no metal is present. On the left, the oscilloscope displays a stable sine wave. The LC tank circuit is oscillating at its natural resonant frequency of 281.93 kHz with a steady peak-to-peak voltage of 1.4049 voltage. Because there is no metal to absorb the energy, the feedback loop maintains a strong voltage swing. This highest voltage keeps the alarm transistor bias off, ensuring the device remains silent. In short, a clean high amplitude signal indicates a clear field. This slide illustrates what happens when metal enters the coil magnetic field. Notice the unstable overlapping waveforms on the oscilloscope. The peak-to-peak voltage has dropped to 1.01 voltage, a decrease of roughly 0.4 from the ideal state. This occurs because the metal induces eddy current, which act like the brake and drain energy from the field occasionally. The metal changes the coil effective inductance, causing the oscilloscope oscillation frequency to shift or slow down. This specific voltage drop is what triggers the transistor to turn on, sounding the alarm. In short, metal absorbs energy, collapses the voltage, and triggers the alert.
Hello, my name is SULAIMAN TANJUNG. For the third graph, this graph illustrates the physics of energy dissipation damping. It typically occurs when the oscillator is engaging or disengaging. Or if the metal object is so large, it completely kills the oscillation. It visually proves that the circuit relies on the stored energy swinging back and forth when resistance from the metal target becomes too high. The energy is exhausted and the wave collapses. Assalamualaikum warahmatullahi wabarakatuh. Pada hari ini saya akan testing projek Electromagnetic. Kita akan kesan magnet dan bukan magnet. Kalau magnet dia akan berbunyi macam ni. Itu maknanya medan magnet kita ni berfungsi dan detect magnet, detect besi, iron ke apa ke. Ni dia tak detect. Ini dia detect. Contohnya kunci. Ini plastik, dia tak detect. Tapi apabila kita mengacukan ini kepada besi ini, ini besi ke? Besi kuat. Bunyi sikit. Bagi ikan zip. Saya bawa sini. Kulit dia kita tak dapat detect. Dan apabila kita ke besi dia ni, zip. Ini besi ke? Ini stapler ni. Itu ada contoh dia. Okay, sekian, terima kasih. Ini selepas. For the conclusion, this project successfully demonstrates the practical application of electromagnetic induction and Lenz's law through the construction of a handheld metal detector. By utilizing an LC tank circuit, we are able to visualize how hidden conductive material interact with the magnetic field without physical contact. The oscilloscope they provide critical validation of the underlying physics. specifically showing how induced eddy current create an opposing field that dissipated energy and alter the coil electrical characteristic. The transition from a stable continuous a sound wave to a damper or lower amplitude signal effectively. Proof that environmental disturbance can be detected and converted into an audible alert, fulfilling the project objective to detect objects like coins and wire using basic electronic principle. That's all for me.